Today we're going to talk about planet formation. So the solar nebula theory explains how planets form outside the accretion disk. And according to the theory, the planets form from dust and gas left over from the solar nebula after the formation of the sun. So how long does it take to form a solar system? It takes around 1 to 10 million years. The first step of planet formation is the collapse of the cloud or the solar nebula. Clouds of gas and dust that exist throughout the disk of the galaxy collapse. And why do the clouds collapse? Well, a theory is that the shock wave of the supernova causes the gas and dust from the clouds to become unstable and causes them to collapse. So the second step of planet formation is the accretion disk. As the gravitational pull begins to condense the gas to the center, the speed of the rotation increases and it flattens the cloud, which creates an accretion disk. Matter continues to be collected through gravity. A ball of hot gas is created in the center of the accretion disk, which creates a protostar. The protostar eventually becomes the sun. The temperature of the disk is at different levels depending on how far it is from the protostar. So the third step is the condensation phase. When the temperature of the solar nebula drops, the molecules that make up the disk will create small bodies known as droplets. They will begin to stick to one another through electromagnetic forces until they're big enough to attract other dust grains through gravity. Droplets move in a spinning disk, which makes them collide with one another. The fourth step is the accretion phase. Particles continue to collide and stick to the spinning disk. They continue to grow through collision and gravity. This creates a planetesimal. Planetesimals are the size of a house. Eventually you will get enough of the planetesimals to collide and stick that it forms a planetary embryo. Planetary embryos are the size of a moon. They also collide with each other, which will eventually create terrestrial planets and Jovian planets. And the final step is the competitive growth. As planetary embryos continue to collide with one another, they form even larger bodies. Since the largest planet embryos have the biggest gravity, they draw more bodies towards them. This causes them to become bigger through collision, and eventually there will be less and less planetary embryos. After repeating this process over a long time, only the biggest planetary embryos survive. And this is how the terrestrial planets are formed. These planetary embryos tend to be farther away from each other, and they also have space orbits since they already collided with everything else on their orbit. This explains why the terrestrial planets have low eccentricity, since having high eccentricity causes the objects to collide with something. And this also explains why they have low inclinations. These bodies are flat, and having a high inclination will cause the bodies to be tilted, and it will most likely collide with other objects. So why do terrestrial and Jovian planets have their chemical composition? Well, the temperature drops with distance from the protostar. The inner disk has materials that do not melt in high temperature. For example, metal and rocks. Farther away from the disk, around the frost line, there is ice and high volatile materials, including ammonia ice, because of the low temperature. And the reason why terrestrial planets form near the inner disk is because gas and ice would not be able to survive in the hotter temperatures. This is why the Jovian planets like Jupiter are farthest away from the sun.